Welcome to aminacademy.com. In strength of material, let us discuss about analysis of uniformly tapering circular rod. Here, look at this, the cross section of a tapering circular rod. One end is diameter D1, other end is diameter 2. The axial pull of P is applied and axially. Now, let us write the given things. P equal axial tensile load. Axial tensile load from dia D1 at one end and dia D2 at other end. L is total length of bar. Total length of bar, and E is Young's modulus. Here, look at this figure. You have to take a small element with dx, x distance from one end, that is diameter d1 end, and we have to find dx. Dx is the diameter of the small strip. The thickness dx is equal by geometry. By geometry, we'll do that one. D1 minus D2 over L into x. Now, which is equal D1 minus kx, where let k for simplicity we have D1 minus D2 over L. Now, area of this cross section of cross section of that small element is pi by 4 dx square, which is equal pi by 4 d1 minus kx square. This is the area of cross section. Therefore, now the stress at a distance x, stress at a distance x from left side. That means you have to find the stress in this cross sectional area. That is, we know that stress equal load by area P over pi by 4 d1 minus kx whole square, which is equal 4p into pi d1 minus kx the square. Now the strain we know that strain is stress by Young's modulus E, which is equal sigma x by E. Already sigma x is 4p by pi into d1 minus kx whole square E into E. Now due to this extension of the small elemental length, dx equal strain into dx, that is strain equal 4p over pi E d1 minus k whole square into dx. This is the extension of small elemental length, means due to this axial load, small extension in this elemental area, elemental strip. Now the total extension can be found by integrating. Total extension is dl zero to L 4p dx over pi E d1 minus kx whole square. Now that constant taken out of integration, that is 4p over pi E integral 0 to L dx, that is next is d1 minus kx power minus 2 dx. Now we have to integrate this with respect to x, that is here 4p over pi E, integration of that one is d1 minus kx, minus 2 plus 1 is minus 1 over minus 1 into differentiation of minus kx is minus k 0 to L. So 4p by pi E 1 over minus 1 into k d1 minus kx over 1. Now 0 to L, we will give the value 0 to L now. 4p by pi E 1 over k d1 minus kl minus 0 values gives 1 over k into d1 minus k into 0, which is equal 4p by pi E 1 over k into d1 minus kl minus 1 over k d1. Here So which is now k is taken out, 4p over pi ek 1 by d1 minus kl minus 1 over d1. Now substituting, k equal d1 minus d2 over L. We let k equal d1 minus d2 over L, and we'll get it dl equal 4p by pi ek 1 minus d1 1 over d1 here also k is there, k is d1 minus d2 over L is 1 over d1 minus here k is d1 minus d1 minus d2 over L d1 minus d2 over L minus 1 over d1, which is equal 4 pi e I'll cut here 4 pi e d1 minus d2, this L, this will go up 4pl, now which is 1 by d1 minus d1 plus d2 minus 1 over d1. Here d1 and d1 cut, so we have 4pl over pi e d1 minus d2 1 over d2 minus 1 over d1. Now 4pl by pi e d1 minus d2, take LCM is d1 d2 d1 d2. So this common factor cut both, therefore we have 4pl 4pl by pi e d1 d2, this is dl. Here this is a change in length due to axial load of tapering circular rod, 4pl by d1 d2. Note here, if rod is uniform, that is not tapering, that means uniform means d1 equal d2, therefore you can see here in this uniform rod dl equal 4pl over pi e d square, d1 equal d2, d1 equal to d, suppose we are keeping d here, therefore this is the total extension for uniform rod is 4pl over pi e d squared. From this we got when it is not tapering. We have done. Please subscribe our YouTube channel.